When an alkyl halide is treated with a small base, alkene products are formed through an elimination process. This is a concerted bimolecular reaction which we will call the E2, and Zaitsev's rule will apply, with the more highly substituted alkene being isolated as the major product. In this reaction, the base attacks the substrate, deprotonating at the beta position, and forming a pi bond with loss of the leaving group. This all happened in one step, and that step is known to be bimolecular since it is dependent upon the concentrations of both the base and the substrate. The reaction occurs through a transition state as shown here, and deprotonation can happen at either beta hydrogen to give two regioisomeric alkenes. Since this reaction only has one step, this means that the base removes the proton from the beta position, the pi bond forms, and the leaving group breaks away all at the same time. This process is therefore described as being concerted. We use the dashed arrow here to describe going up a single reaction barrier to the transition state. The E2 is overall described as a single-step reaction pathway. The transition state at the top of this rate-determining step features the concerted formation of an oxygen to hydrogen bond, the breaking of the carbon to hydrogen bond, the formation of the carbon to carbon double bond, and the breaking of the carbon to bromine bond as the bromide is leaving. The driving force for this reaction is the transfer of negative charge from the unstable oxygen in the base to the much more stable and larger bromide anion. The double bond is formed, in this case to give the more highly substituted Zaitsev alkene as the major product. Alternatively, concerted deprotonation on the right-hand side will produce the minor, less substituted Hofmann product. The transition state on the way to this product has fewer electron-donating alkyl groups to help stabilize the developing sp2 hybrid carbons, and so is higher in energy than the corresponding Zaitsev process. When an alkyl halide that possesses at least one beta hydrogen is treated with a strong base, elimination occurs through the E2 mechanism to produce alkenes. The advantage of this method over the E1 pathway is that most alkyl halides will participate, and since carbocations are not formed, there will be no products of rearrangement. The regiochemical outcome of an E2 reaction is predictable, which is very useful in synthetic applications.